Hello dear grade 7 children. Today we are going to learn the 5th lesson of science textbook, that is acids and bases. What do you know about acids and bases? Have you heard of acids and bases before? So under this lesson we are going to learn very interesting things about acids and bases. So we will see what are the topics that we have to learn under this lesson. So first thing we have to learn about acids and bases is identification of acids and bases. So under this part I am going to teach you what are acids, what are the bases, what are the examples for acids and bases, and I am going to teach you there are some other substances that you can use to identify acids and bases, and they are known as indicators. So under the first topic we are going to learn different types of acids, bases, and how to identify them using indicators. And the next one, acids and bases available in school, laboratory and home. So under this topic we are going to learn what are the acids and bases that we can find in the school lab and also at home. So we will start our work. Right children, we are moving to our first topic, identification of acids and bases. What can you see here? You all can see a beautiful fruit basket with a lot of fruits. What are the fruits you can see here, children? I can see here grapes, mandarins, and I can see oranges, apples, and kiwi fruit, and bananas, and some lovi fruits. There are different types of fruits here. What can you tell about the taste of these fruits, children? So we'll start from these bananas. Bananas, like ripe bananas, they are sweet in taste. What about the apples? Red apples normally, very ripe red apples, they are sweet in taste. But green apples are sour in taste, right? And even these grapes. What can you tell about grapes? Grapes, when it is raw, it is sour in taste. And when it is ripe, that is sweet in taste. Okay. What about the oranges and mandarin, children? Now, oranges and mandarin normally sour in taste. Okay. And kiwi fruit, lovi fruit, they are also sour in taste. Now, even though it's not here, what about pineapples? Pineapple is also sour in taste. So, when it comes to fruits, most of these fruits are sour in taste. Right? So, what is the reason for the presence of this sour taste, children? So, sour taste of these fruits present because of a special reason, because of a presence of special chemical substance. Okay, that chemical substance is known as acids. Now you are going to learn about acids. So, what are the acids? Now, fruits have different taste because they contain different chemical compounds. Okay, example like fruits that are sour in taste. We discussed this part already, right? So, the reason for this sour taste is containing acids in them. So, I told you under this lesson we are learning about acids and bases. Okay, children. So the reason for this sour taste is containing acids in them, right? A group of chemical substances called acids. So what are the examples? We will write from the fruit basket. The fruits with sour taste, what are they? Orange, mandarin, even though it was not there in the fruit basket, pineapples, right? So these are the examples fruits. What are the other acids, acidic substances, so sour substances with sour taste that we use in our day-to-day life? What about lime juice? Now lime is also a type of fruit, but most of the time lime juice we used when we cook food. Okay, so what are the other examples? Lime juice. And vinegar is also an acidic substance. Okay, children. So orange, mandarin, pineapple, lime juice, these are the fruits with a lot of acids. Okay. and because they are sour in taste. The reason behind this sour taste is because of containing acids in these types of substances. So apart from these fruits, what are the other substances? Especially when we cook, we use these acidic substances or substances with sour taste. What are they? Vinegar, tamarind, and Garcinia. Garcinia is also an acidic substance. Garcinia is an acidic substance. Okay, so it means even if you did know that these are acidic substances, you've been using these type of acidic substances in your day-to-day life. Understand, children? So, what is the next type of chemical substance that we are going to learn under this lesson, children? That is bases. Now we are going to learn about bases. Okay. So, what are bases, children? What do you know about bases? I am sure this term bases is a new term for y'all because you haven't learned about bases. But do you know that just like acids, you've been using different types of bases as well in your day-to-day life? We will learn about bases. Before we learn what bases are, we will go through these examples. Listen carefully. Number 1. Sodium bicarbonate is used as a treatment for bee sting. Okay, now sodium bicarbonate means baking soda. Sodium bicarbonate is the chemical substance present in baking soda, right? So sodium bicarbonate or baking soda is used as a treatment for bee sting. So what is this bee sting? Bee sting is an acidic substance, children. Okay, so using the special part called stinger or sting, bees can inject these acidic substances to our skin. So it is very painful because of these acids present. So how can you reduce this acidic nature of this bee sting? We can apply some bases. Now when it comes to the sodium bicarbonate or baking soda, it is a type of base. Now acids and bases are chemical substances. They have different properties. Okay, so when it comes to bases, when the bases are mixed with acids, that acidic nature reduces or acidic properties reduces. So in order to reduce the pain of bee sting, because bee sting contains acids, we can apply a kind of base on that wound. So then what happens? These acids mixes with the base and pain is reduced. Okay, the next one. Number 2. Milk of magnesia tablets are taken for gastritis. What is the meaning of gastritis, children? It's a type of disease, okay, or certain condition that takes place in your stomach. So when you eat food, your food goes to your stomach and in the stomach the digestion takes place. So the digestion in the stomach is done by something called gastric juice. Gastric juice. So this gastric juice is a mixture of different substances. One of the substances present in the gastric juice is hydrochloric acid. Hydrochloric is a type of acid. Okay, so gastric juice contains hydrochloric acid. So some of you may like sometimes you don't feel like eating, sometimes you skip your meal, especially your breakfast when you don't have enough time, when you have to go to school, you just skip your breakfast and you run to school, right? But you must have felt after a little while, you feel this burning sensation in your stomach. So what is the reason, children? So when you don't eat food, when your stomach is empty, because of the gastric juice contains this hydrochloric acid, you feel that burning sensation. Okay, children. So what happens? This condition is known as gastritis. So gastritis means increase of acidic levels in the stomach. So how to reduce these acidic levels in the stomach? As I told you in the first example, acidic levels can be reduced by adding basic substances. Okay, children. So milk of magnesia is a type of base. Okay, it's a certain medicine. It contains a base. So what happens when you take this milk of magnesia tablets, it mixes with the hydrochloric acid, and the properties or the amounts of hydrochloric acids are brought down by the bases present in this milk of magnesia. Okay, children. Number 3. Lime is added to reduce the acidity of the soil. What is the meaning of acidity of the soil? So during crop cultivations, the soil nature should be up to a certain standard. It shouldn't be too acidic. So when acidity of the soil increases or the amounts of acids in the soil increases, we can add lime. What is this lime? Is this lime juice or lime fruit? No. This lime is not the lime fruit we eat. Okay. This lime is known as, chemically it is known as calcium oxide. It is a basic substance. Understand, children? So by dissolving this lime or calcium oxide in water, we can prepare lime water, and that lime water is not lime juice. Okay, lime juice is taken from the lime fruit. That is an acidic substance, but this lime or lime water is a basic substance. Understand? So instead of this lime or lime water, we can even add wood ash. Wood ash is also a basic substance. So lime or wood ash is added to reduce the acidity of the soil. So these are 3 instances that we use bases in our day-to-day lives. So when you go through these 3 instances, it's very clear. The problems arise due to acids can be controlled or minimized by using bases. Understand, children? So sodium bicarbonate or baking soda, milk of magnesia and lime water, right here lime or lime water, contain chemical compounds called bases. Now I told you acids, bases, all these substances are chemical substances or chemical compounds. Okay, so here some substances contain bases, chemical substances. Bases can be used to reduce the problems occurring due to acids. These are the examples. Reduce the problems occurring due to acids. And what is the special property of bases? Bases have a soapy nature. Soap-like substances. What is the nature of soap? Soap is slippery. So that unique slippery nature is a special property of soap. So all these bases also have the soapy nature, that slippery nature. So what are the other substances? Now here the examples given: sodium bicarbonate, milk of magnesia, lime water. They are examples of bases. There are some other examples as well. So soapy nature is coming under bases. Therefore, soap is also a type of base. Shampoo, washing powder, wood ash, I mentioned before as well. They all are coming under bases. Okay, so all these substances you use in your day-to-day life. So it means even without you all knowing, you've been using these acids and bases in your day-to-day life. Right. So we learned 2 types of chemical substances, acids and bases. And now you all know that they have totally different properties from each other. Are there any other substances apart from these acids and bases? We will go see. Okay. Neutral substances. What are these neutral substances, children? Now I ask you all a question. Apart from these acids and bases, whether we have another type of chemical substances? Yes, we have. Now I told you acids have one type of properties. What are the properties of acids? Now you all know that acids are sour in taste. Sour in taste. Right? So the reason behind the sour taste, the reason for this sour taste is because of the presence of chemical substances called acids. When it comes to the second type of substances called bases, what is the special property? Bases have a soapy nature, soap-like nature, right? bases have a soapy nature. So what are these neutral substances then? Remember, apart from these acids and bases, there's a third type of substances called neutral substances. They don't show any type of acidic or basic properties. It means these neutral substances do not belong to acids or bases. Okay? Water, alcohol, salt solution. Now these are the examples. Here, water, alcohol, salt solution, kerosene do not show the properties of acids or bases. Okay, so they are called neutral substances. So not only this, now here we have water, alcohol, salt solution, kerosene. There are other examples. Sugar solution. Sugar solution. Glucose solution. Sugar or glucose, they all are coming under neutral substances. Right? Why do we call these neutral substances? Because these substances, they don't show acidic properties or basic properties. Okay, so far we know there are three different types of chemical substances. Acidic substances, which means the substances that are sour in taste. Number two, basic substances. The substances with a soapy nature are known as basic substances. And the neutral substances, the substances that do not show any acidic or basic properties. So, is there a method to identify these acids, bases and neutral substances? Shall we go and see that we are going to do an activity in order to find out these acids, bases and neutral substances? We will go to that now. Right. Acids and bases available in school, laboratory and home. And our activity is, now this is the first experiment we are going to do under this lesson. Okay. Activity is identifying acids, bases and neutral substances. So what are the things that we need to do this activity? Look carefully. We need shoe flowers, right? Because using these shoe flowers, we are going to prepare a special solution. So that solution we are going to use in order to identify acids, bases and neutral substances. Okay, children? So we need shoe flowers. Shoe flowers. And we need lime juice. Lime juice. Now, what is lime juice? Lime juice is an acid, right? Vinegar, vinegar. Vinegar is also a type of acidic substance. And then we need soap water. Soap water, it is a basic substance. Okay? And then we need lime water. Lime water. Now I told you lime water is not lime juice. Lime juice is an acidic substance. What about lime water? Lime water is a basic substance. And then we need ash mixed water. Ash mixed water. So do you remember I explained that wood ash is coming under bases, therefore ash mixed water is also coming under a basic substance. Okay? And then we need a common salt solution. You have to dissolve some salt in water and prepare this one. Common salt solution. And then we need some water. Right. Common salt solution and water coming under neutral substances. So we have two acids, lime juice and vinegar, and we have three bases, that is soap water, lime water and ash mixed water, and we have two neutral substances, okay, common salt solution and water. So how to do this activity? I will explain you. Right. Listen carefully. I told you using that shoe flower we have to prepare a special solution. Okay. So the method, Prepare a solution by boiling shoe flowers. So what do you have to do in order to prepare this solution? You have to put some shoe flower petals into some water and you have to boil it for about 5 to 10 minutes. So you will see very clearly when you do this activity, when you boil the shoe flowers, the color of the shoe flower goes to the water. So after preparing the solution, that solution is red color or the color of the shoe flower. Okay, so we have to prepare a solution by boiling shoe flowers and then prepare different solutions using acids, bases and neutral substances used in day-to-day life. Here, all these substances we used here, we use these things in our day-to-day life. Okay, so examples I mentioned earlier: lime juice, vinegar, soap water, lime water, ash mixed water, common salt solution and water. Right? Now what do we have to do? Next step, put equal volumes of above solutions, which means these solutions. Okay? Put equal volumes of above solutions into separate test tubes. Right? We have 7 different types of solutions. We have to put these solutions into 7 different test tubes. What is the next step? Put 2 drops of shoe flower boiled water. We have to prepare the first step. We have to prepare the shoe flower boiled water. Right? Now we have to put 2 drops of shoe flower boiled water into each of the test tubes and shake well. Okay, so from the solutions you have to take equal amounts, about 2 milliliters, and from the solution or shoe flower boiled water you have to take about 2 drops. Okay, you have to mix them and you have to shake the test tube and check what happens with the color actually, right? So record your observations. Now we are going to do that activity in the lab. You learn about acids, bases and neutral substances. So we are going to do an activity to identify these acids, bases and neutral substances. So you all can see we have some chemical substances here, acids, bases and neutral substances that we can find at home. So look at these children, we have lime juice and vinegar, lime juice and vinegar, acids. And we have soap water, lime water and ash mixed water. So these 3 substances, which means soap water, lime water and ash mixed water, are bases. And then we have common salt solution and water. So common salt solution and water are coming under neutral substances. We are going to do this simple test to identify these acids, bases and neutral substances separately. So what are we going to use to identify these substances, children? We are going to use shoe flower boiled water. So what do you need to prepare the shoe flower boiled water? We need this species of shoe flower. There are different types of shoe flower. So in order to prepare the shoe flower boiled water, we are going to use this type of shoe flower. So how to prepare the shoe flower boiled water, children? So first of all, I am going to put the shoe flower petals to this water. So using a glass rod, you can mix it. And you have to heat the solution. When it starts to boil, you have to leave it for about 5 to 10 minutes under boiling temperature. So after that, what you have to do, you have to filter out these petals and you have to collect the solution, only the liquid part. So it takes time to prepare this one. Therefore, now I am going to use a previously prepared shoe flower boiled water. This is the color. Okay, children. Now you all have to observe carefully what I am going to do. So here I have the same solutions I have taken separately, equal volumes. You all can see, right? So here these 2 test tube contains the 2 acids, lime and vinegar, and these 3 test tubes contain the bases we used, soap water, lime water and ash mixed water. And here we have the common salt solution and water. Those are neutral substances. Now what I am going to do is, I am going to put 2 drops of this shoe flower boiled water into each of these test tubes. You all have to observe what happens. Okay? Right. First I am going to add 2 drops of the shoe flower boiled water to our lime juice. Observe the color change, children. Our lime juice was pale yellow in color. Now it is slightly pink in color. I will take the vinegar. Right. Look at the initial color of vinegar, and I'm going to add 2 drops as before. What is the color change? It is as same as lime juice. Slightly pink in color. Then we'll take our bases. First I am going to take our soap water solution. Two drops. Can you all see? It changes into slight green color, right? It gets a yellowish green. So that is a base. Now let's take lime water. Okay, children. Can you all see? If I take the previous one, they both have the equally same color, pale green in color. Next we'll take ash mixed water. That is also a base. What happens, children? That is also pale green in color. Okay. Now we will take our neutral substances. The first one is our common salt solution. Check what happens. What happens, children? Does the color change? There's no change. You all can see it is still colorless. Okay. And then we will take our water test tube. That is also a neutral substance. And that is colorless. What happens? Is there any color change? There's no color change. It is still colorless. Right, children? So when you observe these acids, bases and neutral substances, the first 2 test tubes contain acids. Now look at the color with shoe flower boiled water. You all can see that is pink in color. Right? When you take our 3 bases or 3 basic substances, you all can see that is pale green in color. Okay, when we add 2 drops of shoe flower boiled water, it gets pale green in color. What about our neutral substances? It does not change color. Neutral substances did not change color. No any color change. So why does this happen, children? Remember, now using the shoe flower boiled water, we can identify acids, bases and neutral substances separately. So there are substances that we can use to identify acids, bases and neutral substances separately. Those types of separate substances are known as indicators. There is a special characteristic of these indicators, children. Remember, when you add indicators to acids, it will give one color. But when you put indicators to bases, it will give a separate set of colors, like this pink color and green color. You all can see with acids, this particular indicator gives pink color. And with bases, this particular indicator gives green color. Okay? What about the neutral substances, children? Remember, neutral substances do not change the color with any indicator. That is the speciality. So I hope you understand how to separate or how to identify acids, bases and neutral substances. Right, children? So you observed what happens with our experiment. Do you remember what are the color changes that took place when we add the shoe flower boiled water to our acids, bases and neutral substances? Here we have the picture taken. I think you can see it very clearly. Right? So, these are the results with acids. Okay? So, lime juice and vinegar we used as acids. This is lime juice, this is vinegar, soap water, lime water, ash mixed water, common salt solution and water. Right? Do you remember that I explained this in the lab? I will write the first two things, first two test tubes, acids and here bases and these two neutral substances. Simply write neutral. So what was the color change, children? Now you all can do this activity at home very easily. So you will realize what are the color changes, just as I did, okay? So what are the color change that took place with acids when you put a few drops of shoe flower boiled water into acids? It gave a very bright pink color, or you can simply say pale red in color or bright pink in color. So actually that is they are shades of red. So we will write here, now here we have the table, the solution we used, whether it's an acid, base or neutral substance, and color given with shoe flower solution. Okay, children. So with lime juice and vinegar, acids gave one color. I will simply write, all together I will write like this, shades of red. What about the bases? We used soap water, lime water and ash mixed water. What was the color given? So we didn't see the same green color in all three test tubes. However, all three test tubes gave a kind of green color. It means shades of green. So when we add the shoe flower boiled water to bases, what happens, children? It turns into green color. Because it's not exactly all, which means all three greens are not the same. I will write it as just like before, shades of green. Shades of green. Right. What happened when you put a few drops of these shoe flower boiled water into these neutral substances, which means our common salt solution and water? Did you see any color change? Right, the beginning of the experiment, now you all know that common salt solution and water, they are colorless. Even after adding the shoe flower boiled water, did you see any color change? No, it was still colorless. It means shoe flower boiled water does not change the color of the neutral substances. Therefore, for the last two things, I will write no color change. No color change. Okay, so when you do this activity at home, children, remember, don't limit to this list. You can find many other acids, bases and neutral substances. Okay, so find them as well. So check whether they also turn, they also change the color in the same way, right? Because when you use more acids, more bases and more neutral substances, the observations are very clear. Okay, so here we used only 7 different types of solutions. However, after doing this activity, it's very clear the shoe flower boiled water gives one type of color with acids and another type of color with bases, right? With acids it gives shades of red. Okay, with bases it gives shades of green color. What's with the neutral substances? Neutral substances do not change the color with the shoe flower boiled water. Okay, children. So after doing this activity, it's very clear that we can use the shoe flower boiled water to identify acids, bases and neutral substances. Okay, so we will write our conclusion now. Acids give one color while bases give another color with shoe flower boiled water. Therefore, shoe flower boiled water can be used to identify acids, bases and neutral substances. Okay, children. So, acids give one color while bases give another color with shoe flower boiled water. Therefore, shoe flower boiled water can be used to identify acids, bases and neutral substances. So, it's very clear shoe flower boiled water is a substance that you can use to identify acids, bases and neutral substances. Okay, children. We'll move to the next. Right. Indicators. Now we did one activity using the shoe flower boiled water and it was very clear you can identify acids, bases and neutral substances using this shoe flower boiled water. So what is this shoe flower boiled water? There are some other chemical substances in our day-to-day life and also in the laboratory that we can use to identify these acids, bases and neutral substances. How do we identify acids, bases and neutral substances using these other type of substances, solutions? They can change the color according to acids and bases. So these type of chemical substances are known as indicators. Okay. So the solutions or the things that give different colors with acids and bases are known as indicators. Indicators, right? So how can we identify acids and bases? Because acids and bases give different colors with the presence of indicators, right? So the things that give different colors with acids and bases. Okay. So under this lesson, you are going to learn about different types of indicators. So when it comes to indicators, children, basically, we are going to learn it under two topics, right? So indicators, some of them are natural indicators. Now, shoe flower boiled water is a type of natural indicators. I will explain what are the natural indicators later, right? Natural indicators and other indicators we can see in the lab. Natural indicators and indicators used in the lab. Indicators used in the laboratory. Okay, so when we learn about indicators, we are going to learn about natural indicators and some other indicators used in the laboratory. Okay, children. So, however, indicators can be used to identify acids, bases and neutral substances. So when you learn about indicators, it's very important that neutral substances do not change the color with indicators. Do you remember when we add these shoe flower boiled water to acids, it gave a range of red color, right? With bases, it gave a range of green color. What happened with the neutral substances, our common salt solution and water? Did it change the color? It did not change the color. It means indicators do not change the color along with neutral substances. When we do our other experiments, you will understand this better. Okay, now we are going to do our second experiment. Okay, our next activity is identifying acids, bases and neutral substances using litmus paper, right? Now remember children, this litmus paper is also a type of indicator that we can find in the lab. Okay, I told you there are two different types of indicators, natural indicators, we are going to learn about that as well, and some other indicators that we can use in the lab. So litmus paper is a type of indicator that we can use in the lab. And remember, litmus paper comes in two colors, that is red litmus and blue litmus. Okay, so look at this one. What are the materials we need to do this activity? Now this is the blue litmus, right? They are strips of paper, right? It comes as a strip. So blue litmus, blue litmus, and we need red litmus, red litmus. And apart from blue litmus and red litmus, other substances we need are the same solutions we used in the first experiment, right? Look at this one, lime juice, we will write that, lime juice, vinegar. So lime juice and vinegar come in under acids. Then we need soap water, lime water, and ash mixed water, So soap water, lime water and ash mixed water come in under basic substances. And then finally we need common salt solution, and some water. So common salt solution and water come in under neutral substances. So what do we need? Blue litmus, red litmus. We are going to use this blue and red litmus as our indicators, right? Lime juice, vinegar, soap water, lime water, ash mixed water, common salt solution and water. We will see how to do this activity now. So as before, we have to prepare the same set of solutions, right? Prepare different solutions using acids, bases and neutral substances used in day-to-day life, right? So the same examples are given as we used in our first experiment. And then use red litmus and blue litmus with above solutions to identify the acids and bases and record the observations. So what you have to do, we have to take a strip of these red litmus and blue litmus and we can immerse them in each of these solutions and we can check whether there is any color change. We will do that activity now. Right children, now we are going to identify acids, bases and neutral substances using litmus paper. I explained you that litmus paper is a type of indicator and litmus paper comes in two colors. What are the two colors children? Red and blue litmus. So I will show you. This is the red litmus. You all can see it's a strip of paper. It is pale red in color. And this is blue litmus. It is pale blue in color. Okay. So we are going to use the same solutions we used in the first experiment. We have lime juice and vinegar as acids, soap water, lime water, ash mixed water as bases, and then we have common salt solution and water as neutral substances. So now You all can see I have placed red and blue litmus paper in front of each of these solutions. I am going to add a drop of each solution on this litmus paper now. You all have to observe the color change carefully. Okay. We will start with lime juice. I will take some lime juice and I am going to put a drop of lime juice, 2 drops into this red litmus. Look, what is the color change, children? You all can see there's no any color change. It is still red in color. Now I'll put a drop into blue litmus. Right. You can see how the blue litmus changes into red color. So the red litmus does not change color with lime juice, but blue litmus turns into red color. Okay. Now we will take vinegar. I will put a drop of vinegar on red litmus. Is there any color change, children? There's no any color change. Then I will put it into blue litmus. What happens, children? The blue litmus instantly changes into red color. Okay, so when you put vinegar into red litmus, there's no any color change, but blue litmus turns into red color. Okay, children? Right. We will go with the bases now. I will take some soap water and put a drop on red litmus. What can you see, children? The red litmus turns into blue color. Okay, it slowly changes to blue color. Okay, children, right. Now I will put a drop of soap water to blue litmus. Is there any color change, children? What can you see? It is still blue in color. Now we will check with lime water. We'll put a drop into red litmus. Look at the color change, children. And into blue litmus. What happens to the red litmus, children? It turns into blue color. And blue litmus, there's no any color change. Okay? So that is with lime water. Next we will check ash mixed water. I will put a drop onto red litmus. You can see the red litmus slowly changing into blue litmus, children. Right? If I put a drop onto blue litmus, there's no any color change. If you observe carefully, you can see this red litmus slowly changes to blue color. Okay, children? Okay. And then we will do the same activity with common salt solution. I'm going to test this with common salt solution. We drop onto red litmus. And some common salt solution onto blue litmus. Is there any color change? You can observe carefully. Red litmus does not change color. Even the blue litmus does not change its color. Red litmus is still red in color. Blue litmus is still blue in color. Then finally we will test the litmus paper with water. Water on red litmus and on blue litmus. What happens, children? Is there any color change? Again, there is no any color change. You all can see red litmus is still red in color, blue litmus is still blue in color. Understand, children? So, if you go from the beginning, now you can look at the lime juice and vinegar. They are acids. Now you can see this blue litmus is totally turned into red color. Okay, red litmus, there's no any color change. So initially, this is where the red litmus was present. It is still red in color. This is where the blue litmus was present. Now it is completely turned into red color. What about vinegar? Again, red litmus and blue litmus both red color. It means red litmus no color change, but blue litmus turns into red color. What about these bases, children? We use 3 bases: soap water, lime water and ash mixed water. So what happens? Blue litmus, this was the initial color. It is still blue in color. What happened to the red litmus? Red litmus also turns into blue color. Okay, lime water, that is also again red litmus turns into blue color, but blue litmus no any color change. What about ash mixed water? Blue litmus, there's no any color change. Red litmus, you can see this spot, it has changed its color into blue. Okay, children, it means red litmus turns into blue color. We will go to our neutral substances, our common salt solution and water. You all can see red litmus does not change its color. Blue litmus also does not change its color. Even with water, red and blue litmus, they do not change the color. So what is the conclusion that you can come up with after doing this activity? So we can come to a conclusion that the color of the litmus paper in an acidic medium is always red color. And the color of the litmus paper in a basic medium is always blue color. What's with the neutral substances? We even learned before that indicators, any type of indicator does not change the color with any neutral substance. That is why red litmus remains red and blue litmus remains blue color. I hope this activity is very clear now. So you watched the experiment, so it's very clear what were the observations, right? So observations, here I took the same observation as a picture, so it's very clear. Okay, so you remember, now these are the litmus papers we used. Okay, our red litmus and blue litmus. And what happened? When we put a few drops of lime juice on this litmus paper, red litmus, did it change the color? No. Red litmus did not change the color, but blue litmus turned red. Okay, and even with vinegar, what happened? Red litmus did not change the color, but blue litmus turned red. Okay, what happens with bases? We use soap water, lime water and ash mixed water. What were the color changes? Did blue litmus change color with bases? No, it did not. Right? Blue litmus did not change the color, but red litmus turned blue color this time. Okay, children. So it means in an acidic medium, the color of the litmus paper, no matter whether it's red or blue, the color of the litmus paper in an acidic medium is always red. Right? So the second clue, all the litmus color in a basic medium is blue color. The presence of a basic medium, the color of the litmus paper is always blue color. What about the neutral substances? Did red litmus change the color with neutral substances? It did not. What about the blue litmus? Blue litmus also did not change the color with neutral substances. It means litmus paper or any other indicator, as I told you before, does not change the color with neutral substances. Understand, children? Okay, we will write. So here we have type of litmus, red and blue, color with acids, color with bases, color with neutral substances. Okay, we will write here red litmus color with acids. It is still red. It means it does not change the color. What is the color of blue litmus with acids in an acidic medium here? Both the litmus papers, red color. So blue litmus also turns red. Right. Then color with bases. What happens to the red litmus? Red litmus turns blue. Okay, so red litmus, here color with bases, blue color. And blue litmus does not change the color, right? It is blue. With neutral substances, what happens to the red litmus? It does not change color, therefore it is still red. And blue litmus, it is still blue. It means blue litmus also does not change the color with the presence of neutral substances. Okay? Right. So after doing this experiment, what is the conclusion, children? What can you decide after doing this activity? So with the presence of acids, red litmus and blue litmus both shows red color. Right, with the presence of bases, the color of the litmus is blue color. And with the presence of neutral substances, any type of this red or blue litmus do not change the color. Therefore, litmus paper can be used to identify acids, bases and neutral substances, which means it's a good indicator. Okay, we will write this. We'll write the first one. In the presence of acids, blue litmus turns red and red litmus does not change the color. In the presence of bases, red litmus turns, what is the color, children? Blue color. Red litmus turns blue. And what about blue litmus? Does not change the color. And blue litmus does not change the color. The next one, in the presence of neutral substances, both red and blue litmus do not change color. Therefore, we can use litmus as an indicator, right? Therefore, litmus acts as an indicator. Okay, children. So in the presence of acids, blue litmus turns red and red litmus does not change the color. And in the presence of bases, red litmus turns blue and blue litmus does not change the color, right? In the presence of neutral substances, both red and blue litmus do not change the color, right? Therefore, litmus acts as an indicator. So after doing this activity, it's very clear blue and red litmus can be used as indicators in order to identify acids, bases and neutral substances. Now we are going to learn about some natural indicators. Okay, so I explained that there are natural indicators and other indicators that we can use in the lab. So here we have some natural indicators. We will see. Indicators can be prepared by using some materials in the natural environment. Given below are some of them. So the first one, shoe flower boiled water. We already used that in the first activity, right? An extraction of Giratina flowers. Now here this is the Giratina flowers, right? Giratina flowers, so elephant creeper. And extraction of Nil Cattarallu or blue Cattarallu, right? The common name is butterfly pea. Okay, this is blue Cattarallu. Remember, when it comes to this Cattarallu plant, there are two types, blue one and white one. So to prepare this particular indicator, we need to use the blue Cattarallu, okay, or butterfly pea. And areca nut boiled water, okay, and turmeric boiled water. So red cabbage boiled water. This is the dark purple color cabbage that we use to make salads. Okay, children, right. So these we can prepare all these solutions in the same way. I explained you how to prepare the shoe flower boiled water, remember? So we can prepare all these other solutions also in the same way. Okay, so these solutions can be prepared and we can test our acids, bases and neutral substances along with these indicators. Okay, children. So Giratina, blue Cattarallu and red cabbage solutions we can prepare the same way we prepared the shoe flower solution, right? So areca nut and turmeric boiled water, when we prepare them, we have to take the areca nut pieces and turmeric and we have to crush it really well and you have to mix it with water and boil it. Okay, children. So remember, we can't find all these substances in our environment, but you all can try to do these activities with at least a few of these substances. Okay, all these natural flowers and some of these substances you can find in your environment. Try to do these activities, children. These are really easy. Okay, so now we are going to do an activity using some of these natural indicators. The next activity is identifying acids, bases and neutral substances using natural indicators. Now I gave you examples for many natural indicators, but under this experiment I am not going to use all of them. We are going to use 3 natural indicators, right? We are going to use our shoe flower boiled water, turmeric boiled water, blue Cattarallu extraction along with all the other solutions, right? We will write them. We have shoe flower boiled water. Turmeric boiled water. Blue Cattarallu extract. Blue Cattarallu extraction. And lime juice. Vinegar. We need lime juice, vinegar, soda water and colorless soft drink. Okay, children, remember, lime juice and vinegar, you all know that they are coming under acids. And soda water and colorless soft drinks also come in under acidic substances. Okay. Soda water, colorless soft drink. Colorless soft drink. And then we need lime water. It's a base. And then we need soap water, shampoo water, right. Lime water, soap water and shampoo water are the bases we are going to use. Okay. And then we need common salt solution, sugar solution, and then glucose solution, and finally kerosene. Okay, children. So as the indicators or the natural indicators, we are going to use shue flower boiled water, turmeric boiled water and blue Cotterello extraction. And as our acids, we are going to use lime juice, vinegar, soda water and colorless soft drink. And as our bases, we are going to use lime water, soap water and shampoo water. And finally, as our neutral substances, what are we going to use? Common salt solution, sugar solution, glucose solution and kerosene. So I hope it's very clear how to do this activity because we did the similar activities before as well. Okay, we will see method. Prepare the above indicators. I explained you how to prepare the indicators and add a few drops of those indicators to the solutions given above, right? So we use different types of acids, bases and neutral substances that are used in our day-to-day life, right? And record the color you observe. So you all know by now, indicators when we add to acids, they give one type of colors and with bases it gives another type of colors. So you have to record the colors that we can observe under this experiment. Now we will go do this activity. We learn about different types of natural indicators and now we are going to do this activity with some of the natural indicators that we discussed about. So what are the natural indicators we are going to test with? We are going to test with shue flower boiled water, turmeric boiled water and extraction of blue Cotterello. But when you do this activity at home, if you can find the other substances, you can make those indicators as well. Okay, children? So I am going to test these natural indicators with different types of substances, acids, bases and neutral substances that you can find at home. So what are the substances? We will see. We have lime juice, vinegar, soda water and colorless soft drink. Now these four substances are acids. Okay, children. So when you consider soda water and colorless soft drink, they are slightly acidic. And then we have lime water, soap water and shampoo. They all are basic substances. Okay. And then we have common salt solution, sugar solution, glucose solution and kerosene as neutral substances. Now first I am going to check all these substances with shue flower boiled water. So I am going to put 2 drops of shue flower boiled water into each of these test tubes. You all have to check what happens with the color, okay? First with lime juice, vinegar, soda water and colorless soft drink. and then we will add shea flower boiled water to lime water, soap water, shampoo, and then finally I am going to add the shea flower boiled water to common salt solution, sugar solution, glucose solution, and to kerosene. Right. So you all can see it's starting to change the color. I am going to shake each test tube and we can compare the colors then. See, I hope you can see these acids give one type of color, bases give another type of color, likewise. Okay, children. What can you see after adding 2 drops of shea flower boiled water to these solutions? Can you see first we have 4 acids: lime juice, vinegar, soda water and colorless soft drink. They all are acidic substances. Can you see all these 4 acidic substances, they give a pink color range. They are not exactly the same colors, but it ranges. Okay, the pink color range is given. Or the first 2 when you take, you can even consider them as a pale red color as well. Okay, children. So this is the color given by the acids when you add shea flower boiled water. So what about the bases, children? Now shampoo is a very weak base, but that's why it doesn't give the color really well. But when you look at the basic substances, it gives pale green color. Okay, so acids give pink color range and bases give green color range. What about the neutral substances, children? Is there any color change? Now, initially when you took this common salt solution, sugar solution and glucose solution, they all are colorless. Kerosene oil, pale pink in color. Okay, so it remains the same. All the colors remain the same. There's no any color difference. You all can see common salt solution, sugar solution and glucose solution. They all are still colorless. What about the kerosene? Initial color was pink. Even now it is pink. It means there's no any color change. So you can clearly observe when you take shea flower boiled water as the indicator how these acids, bases and neutral substances give colors. Right. Now I'm going to test the same set of solutions with turmeric boiled water. We will do that now. Okay, children. Now I have another set of the same solutions. We are going to check these solutions with turmeric boiled water. We will do that now. Lime juice, vinegar, soda water, soft drink, then lime water, it's a base, soap water, shampoo, common salt, sugar solution, glucose solution, and kerosene. Right. I'm going to mix it well by shaking. So some of the test tubes you can already see the color change. This is soda water, soft drink. Look at the lime water solution, children. And soap water, shampoo, common salt solution, sugar solution, glucose solution, and kerosene. Okay children, so can you all see there's a color change when you compare the acids, bases and neutral substances. So the first four solutions are acids: lime juice, vinegar, soda water and colorless soft drink. So what is the color you all can see? It's a yellow color range. Okay children, it's a yellow color range. What can you tell about the next three test tubes? They contain basic substances: lime water, soap water and shampoo. Can you all see? It is an orange color range. Okay children, it is an orange color range, or you can even say reddish orange color. If you carefully observe the soap water solution, it is reddish orange in color. Okay children, look at the last four test tubes children. They contain neutral substances. There's no color change in each of these test tubes. What is the reason? They contain neutral substances. Okay, so the first three solutions initially also they were colorless. They look almost colorless here. What about the last one, kerosene oil? Original color is pink color, and even after adding the indicator it is still pink in color. Okay children, so it means with turmeric boiled water, acids give a yellow color range and bases give a dark orange color range, and neutral substances do not change color. Now we are going to test the same set of solutions with the extraction of blue Kataruru. We will do it now. Okay children, now here I have the same set of solutions, a new batch. I am going to test these solutions with extraction of blue Kataruru. Look at the color of blue Kataruru solution. It's blue in color. So first we are going to add it to the set of acids. And then to the neutral substances. So we'll mix it well for better observations. It's slightly purple in color. Pinkish purple. So it means a purple range with acids. What is the color with the bases, children? Slightly blue color, blue and brown mixed. It's a kind of pale blue, if you can observe clearly. What about the neutral substances, children? No color change. So all the neutral substances they have the initial color. Okay, so it's very clear after adding these drops of blue Cartarello to our solutions, acids show this pinkish purple color. It's a color range actually, right? And pale blue color range is given by the basic substances, and neutral substances, there's no any color change. So I hope after doing this activity, it's very clear natural indicators also can be used to identify acids, bases and neutral substances. So you watch the experiment, it's very clear using our natural indicators that we can identify our acids, bases and neutral substances we used. Okay, here we have our observations. I'm going to write in front of them what are the solutions. Okay. Like that. So the first indicator we use. These are the observations related to our shoe flower boiled water. And here for the turmeric boiled water, and the last one for the blue Cartarello extraction. We will write shoe flower boiled water, turmeric boiled water, next one, turmeric boiled water, and finally blue Cartarello extraction. Blue Cartarello extraction. Shoe flower boiled water, turmeric boiled water and blue Cartarello extraction. We will move this back. Okay. And we will write the observations. So the first one, shoe flower boiled water. Here in this table I have separated acids, bases and neutral substances. Okay, the first four acids are lime juice, vinegar, soda water and colorless soft drink. They are all acids. And then lime water, soap water, shampoo are coming under bases. And then common salt solution, sugar solution, glucose solution and kerosene are coming under neutral substances. Okay. So we will write a common observation here. I'm not going to write it separately under each solution. Okay. I'm going to write a common color change for acids, bases and neutral substances. So the first one, shoe flower boiled water. What is the color change of shoe flower boiled water with acids? It gave a red color, right? So we will write shades of red. Pinkish red actually, shades of red. Shades of red. And with bases, it's a kind of green color, okay? Shades of green. Shades of green. And what about neutral substances? You all can see no color change. Okay, there's no color change with neutral substances. No color change. Okay, so the second one, turmeric boiled water. What happened when you add a few drops of turmeric boiled water to acids? It gave a range of yellow color. Look at this one. You can see now here the second one is a little dark yellow color, but the other two vessels are pale yellow color, right? So therefore we will write shades of yellow. Turmeric boiled water with acids, shades of yellow. Okay. What about the bases? Bases gave a dark orange color or a reddish orange color. Okay. Here bases reddish orange. And finally the neutral substances, no color change. Okay. No color change. Right. Finally, blue Cartarolo extraction. What happened, children? Do you remember? Now here, when we added the few drops of this blue Cartarolo solution to our acids, what happened? You can see the first two test tubes, they are purple in color, right? The next two test tubes, which contain soda water and colorless soft drink, they are very pale purple in color, right? So we will write here purple, or shades of purple also correct. Purple. Okay. What about the bases? With bases, this blue Cartarolo solution gave pale blue color, right? Here the first two test tubes, you can't see it very clearly because it was really pale. But if you observe carefully the third test tube, it's very clear. Okay. So we will write pale blue. Pale blue color. And with the neutral substances, again, there's no any color change. So if you observe carefully, you can see the common salt solution, sugar solution and glucose solution, they all are colorless, right? What's with kerosene anyway? It was, its initial color was a very pale pink color. All these colors were the same even after adding all these indicators, okay? So here also no color change. No color change. Okay, children. So it's very clear after doing this activity, these type of natural indicators can be used to identify acids, bases and neutral substances separately. Okay, we will write the conclusion. Write the conclusion. Acids, bases and neutral substances. Neutral substances can be identified using natural indicators. Okay. Acids, bases and neutral substances can be identified using natural indicators. So you all can do this activity at home even if you can't find all the solutions, all the natural substances that we use to prepare these natural indicators. Try to find at least a few of them. So you will understand this really well. Okay, children? Next we are going to learn the acidic and basic substances in the school laboratory. So we learn what are the acids and bases and neutral substances that we used in our day-to-day life. Apart from those acids and bases, remember children, when we do different activities or experiments in the school lab, we use other acids and bases as well. So what are they? Have you learned about these acids and bases before? I think you all have learned under the other lessons as well, right? So some acids that are used frequently in the laboratory. So the first one, sulfuric acid. Now sulfuric acid. So do you remember in the third lesson we learned about our simple cell? So there we use the dilute sulfuric acid in order to prepare the simple cell. Okay children. So sulfuric acid is a type of acid. And the next one, nitric acid. And hydrochloric acid. Hydrochloric acid is also very commonly used in different activities in the lab. Okay children. So sulfuric acid is again used to prepare battery acid. We learned this before as well. Okay. So we will write some acids that are used frequently in the laboratory. Hydrochloric acid. Hydrochloric acid. Sulfuric acid. Nitric acid. Nitric acid. Right? Hydrochloric acid, sulfuric acid, nitric acid. Now remember, when these acids are concentrated, they are very strong. Okay? They can even harm us. Therefore, you have to be very careful when you handle these types of acids. But by mixing these acids in water, you can dilute the acids. So thereby, by mixing this hydrochloric acid, sulfuric acid and nitric acid in water, you can prepare the dilute solutions of these acids. Okay, so most of the time in the laboratory we use these type of dilute acids as well for our experiment. Okay, right. So that's about the acids. You can see here, these are the labels of the acids. If when you go to the lab, you can observe these things carefully, right? So the chemical formula is also given apart from the common name. Understand children? We will move to the next one. Next, some bases that are used frequently in the lab. Okay, what are the bases? Here you can see sodium hydroxide. Now look at this bottle, the label says sodium hydroxide. Okay, so the sodium hydroxide, now these are the crystals of sodium hydroxide. You can dissolve these sodium hydroxide crystals in water and then we can prepare the sodium hydroxide solution. Okay, and the next one here, potassium hydroxide. Look at the label here. It says potassium hydroxide and this is solid potassium hydroxide. So by dissolving this potassium hydroxide in water, we can prepare the potassium hydroxide solution. Okay, so these type of bases we can find in the lab. We will write sodium hydroxide, potassium hydroxide, calcium hydroxide is another example. We will write that as well. Calcium hydroxide. Okay children, so when you go to the school lab, you can observe how these labels mention their chemical formulas and what are the instructions given, the information like that. Okay, right. So we learn about some natural indicators and we even learned that how to prepare these natural indicators and we did an experiment using these natural indicators. And when I was explaining about these natural indicators, I explained that apart from natural indicators, there are other indicators we can use in the lab as well. So what are these other indicators? We will see. So apart from litmus, now litmus is a type of indicator that we can use in the lab. Okay. So apart from litmus, the following indicators can be used to identify acidic, basic and neutral substances in the laboratory. What are they? pH papers. Now litmus is a type of paper, right? Litmus comes in two colors, red and blue. Okay. Now pH paper also, it's also type strip of paper. Its color is yellow in color. Okay, children. And phenolphthalein indicator and here methyl orange indicator, they both are solutions, liquids. Okay, children. So pH papers, red litmus, blue litmus, phenolphthalein, methyl orange indicators, they all are coming under the indicators that we can use in the lab. Remember children, these are only some of the indicators we most commonly used in the lab. There are some other indicators as well. If you read books, you will find thymol blue, bromothymol blue, those type of names are also there. They are also coming under indicators, right? There are a number of indicators, but these are the most commonly used indicators in the school lab. Okay, children? Right. Okay. Now we learn about different types of indicators that we use in the lab. Now we are going to learn the color changes of the indicators with acids and bases. So neutral substances do not give any color change with any indicators. Therefore, in this table we have added acids and bases. Okay. So what is the first indicator? Litmus paper, blue litmus. Now you all know that blue litmus and red litmus, how they change the color according to the presence of acids and bases. Okay. So what happens? Blue litmus, what is the nature of the indicator? It's a kind of blue colored paper strips. I showed you this in the lab, right? It's a pale blue in color. And color with acidic substances? When you put a few drops of acids onto this blue litmus, what happens, children? It changes to red color. Okay. Did blue litmus change its color with bases? It does not, right? So blue litmus, color with basic substances, it is still blue in color. Okay. And then red litmus. Red litmus is also a kind of red colored paper strips, pale red in color. And what is the color with acidic substances? Now, do this red litmus paper change the color with acidic substances? It does not change the color, right? So, red litmus, it is still red color. And with basic substances, what happens to the red litmus, children? It turns blue. Which means the color of the litmus paper in an acidic substance is red, and color of the litmus paper with basic substances is always blue color. Okay, children. Next one, pH papers. So pH papers, I explain you, it's also a type of paper. It's a yellow color paper, a kind of yellow colored paper strips. Okay. So what is the color with acidic and basic substances? Now remember children, the special feature of these pH papers is by using pH papers, we can identify strong acids and weak acids and strong bases and weak bases as well. Now look at this litmus paper, red and blue litmus paper with any kind of acid, either strong or weak acid, it always gives one red color. Okay, the color range does not change. It's always the same red color. And even with bases, it is the same, right? No matter what the base is, and a strong base or a weak base, it will still give the same blue color. But remember children, when it comes to these pH papers, it changes the color along with the nature of the acid and base, right? So with strong acids, it gives one color. With weak acids, it gives another color. With strong bases, it gives another color. And weak bases, it gives a different color. So by using the pH papers, we can identify acids and bases. Not only that, what are the strong acids and what are the strong bases as well. And what are the weak acids and what are the weak bases as well. Okay, so we have a special color code in order to identify these different types of acids and bases using pH papers. I'm going to show it next. Okay, so pH papers, a kind of yellow colored paper strips. So color with acidic substances, different colors. Okay, So it gives red, orange or yellow color. Okay, remember children, so if the acid is a very strong acid, it gives a red color. Okay, with weak acids, it gives yellow color. Okay children, that's why I said using these pH papers, we can identify what are the strong acids and weak acids likewise. Okay, so color with basic substances, here it gives dark green, blue or violet. Okay, so with weak bases it gives dark green color, and with strong bases it turns violet color. Okay children, so pH papers are yellow in color. What will happen if we put a piece of pH paper into neutral substances? Will it change color? No, it does not. Right? We'll move to the next. Okay. The next indicator, phenolphthalein. I told you pH paper and litmus paper, they all are solid parts. It means they are papers, right? But when we take phenolphthalein and methyl orange, they are solutions, liquid form. Okay. So phenolphthalein, what is the nature of the indicator? It's a kind of white powder. This powder is dissolved in ethanol or surgical spirit. Right? In order to prepare the solution, this phenolphthalein solution, we have to dissolve this phenolphthalein powder in ethanol or surgical spirit. Okay, the solution is colorless. Okay children, so what is the color with acidic substances? Remember, solution is colorless. It does not change the color with acidic substances. It means with acidic substances, the color of phenolphthalein is still colorless. Colorless, right? And color with basic substances. Now when we add a few drops of phenolphthalein into a base, it turns into a very beautiful bright pink color. Okay, so color with basic substances. Okay, then the next one is methyl orange. So it's a kind of yellow powder, yellow, or sometimes it is dark orange in color as well. Okay, and this powder is dissolved in water and the solution is yellow color. Right children, solution is yellow color, sometimes it's dark orange in color as well. Okay children, so it should dissolve, you should dissolve it in water in order to prepare the solution. So here methyl orange, what is the color with acidic substances? Methyl orange turns red color with acids. It turns red with acids, and with bases it is yellow in color. With bases it is yellow in color. Okay children, so we'll go from the beginning. So when it comes to blue and red litmus, they are kind of blue color and red color paper strips, right? So litmus color with acids always red color. It means red litmus does not change the color with acids, blue litmus turns red. With bases, the color of litmus paper is always blue. It means blue litmus does not change the color with basic substances, but red litmus turns blue color, right? And pH papers, it's a kind of yellow color paper strips, and with acids, red, orange or yellow color, and with bases, it is dark green, blue or violet color. Okay, right. The next one, phenolphthalein, is a kind of white powder. We have to dissolve it in ethanol or surgical spirit in order to prepare the solution, and the solution is colorless. Okay, and the color of phenolphthalein with acidic substances is still colorless. It means it does not change color, and with basic substances it turns pink, right? And the last one, methyl orange, it's a kind of yellow orange color powder. This powder is dissolved in water and the solution is yellow color or dark orange in color, right? So the color with acidic substances is red and the color with basic substances is yellow. Okay, right. So look at this picture. Now pH papers. Do you remember I told you using pH papers we can identify not only acids and bases, but when it comes to acids we can identify what are the strong acids, what are the weak acids, and what are the strong bases and what are the weak bases as well. Okay, and at the same time I told you that there's a color code in order to identify these acids and bases. Okay, so look at this one. This is that color code, children. Okay, you can see that color code is numbered from 1 to 14. Okay, 1 to 14. Remember, acidic substances belong to pH 1 to pH 6. Okay, pH from pH 1 to 6, acids are indicated. And pH you can see from here, pH 8 to 14. pH 8 to 14 gives bases. pH 1 to 6 acids, pH 8 to 14 bases. What about neutral substances? So in between you can see pH 7. pH 7 belongs to neutral substances. Okay, children. So look at this one. So let's say that if you use a certain solution, if you immerse a piece of this pH paper and if it turns red color, it means it's an acid. So how to identify strong acids and weak acids? Remember, children, so when this value goes away and away from 7, it means now here when it comes to 1, 1 is away from 7. But 6 is close to 7. 7 is the neutral substance. Okay, 7 belongs to neutral substances. 6 is closer to 7. It means if a certain acid falls under 5 or 6, they are coming under weak acids because they are closer to neutral substances. When this number go away from 7, the acidity increases. It means, children, now pH 1, 2, 3 belong to very strong acids. Okay, and pH 5, 6 belong to weak acids. So another example, if you immerse a piece of pH paper in a certain liquid and if it gives this orangish yellow color, it means it is a weak acid. Understand, children? So pH 1, 2, 3 belong to strong acids and pH 5, 6 belong to kind of weak acids. Okay, and pH 7 is neutral substances. What about the bases side? So from pH 8 to 14 come in under bases. Now again, as I told you, when these numbers go away and away from 7, the basic nature increases. It means, now look at this 14. 14 is away from 7. Right? pH 12, 13, 14 belong to strong bases. When it comes to 8, 9, they are closer to 7. It means their basic nature changes. Right? Basic nature fades away and it gets close to neutral substances. So pH 8, 9 come in under weak bases. Understand, children? pH 12, 13, 14 belong to strong bases. So for example, if you immerse a piece of pH paper in a certain solution and if it turns this dark purple color, violet color, it means that particular solution is a strong base. Understand, children? So that is how, using the color code, you can identify what are the strong acids, what are the strong bases, what are the weak acids and what are the weak bases. Right? When you immerse a pH paper in a certain solution and if it does not change the color, it means it is a neutral substance. Okay? So you have to memorize these values, children. pH 1 to 6 acids, pH 8 to 14 bases, pH 7 means neutral substances. Understand? Right. So here sometimes the color code comes as a circle. Okay, children. Now the next one. phenolphthalein solution. Now here this is the phenolphthalein powder. So you remember how to prepare this phenolphthalein solution. How do we do that? We can dissolve this phenolphthalein powder in ethanol or surgical spirit. And the solution is colorless phenolphthalein solution, right? So with acids or with acidic substances, phenolphthalein does not change the color, okay? But with bases, it gives a bright pink color. Understand? We'll move to the next. Right. Methyl orange powder. I told you methyl orange powder is yellow or dark orange in color. This is the powder. And by dissolving this methyl orange powder in water, we can prepare the solution. Right? Methyl orange solution. Now in this bottle it is dark orange in color. Dark orange or yellow in color. Right? And with acids, color is red, and with bases, color is yellow. Understand, children? Now we are going to do an experiment using these different types of indicators that we can use in the lab. Activities: identifying acids, bases and neutral substances using indicators. So this time we are going to use the indicators that we can find in the lab. So you are very familiar with these type of experiments now. We did a lot of experiments using the indicators that we can prepare at home, which means natural indicators. So we will see what we need to do this activity. So we need blue litmus, red litmus, here pH papers. I will show these things in the lab, okay? And phenolphthalein solution and methyl orange solution. So these 5 things we are going to use as our indicators. And as the solutions we are going to use 2 acids and 2 bases, okay? So the 2 acids we are going to use is dilute hydrochloric acid, dilute sulfuric acid, and as 2 bases we are going to use dilute sodium hydroxide and dilute calcium hydroxide, which means lime water. Okay, we will write this. Blue litmus, red litmus, pH paper, phenolphthalein solution, and methyl orange solution. Methyl orange solution. As indicators, we use these 5 different types of substances and hydrochloric acid, sulfuric acid, and sodium hydroxide, and calcium hydroxide. Okay. As indicators we use blue litmus, red litmus, pH paper, phenolphthalein solution and methyl orange solution. As acids we use hydrochloric acid and sulfuric acid, and as bases we use sodium hydroxide and calcium hydroxide. So how to do this activity? The method is use these indicators, use pH papers, red litmus, blue litmus, phenolphthalein and methyl orange indicators with the above solutions, which means our 2 acids and 2 bases, right? With the above solutions to identify the acids and bases. Now we will go to the lab and see how to do this activity. Okay, children. Now you all have a good idea about acids, bases and neutral substances, and also about indicators. So I already explained you what are the acids and bases that we can find in the lab, and also what are the indicators that we can use in the lab. Now we are going to do this activity using this acids, bases and the indicators that we can find in the lab. Okay children. So look at this children. This is dilute hydrochloric acid, a colorless solution. And this is dilute sulfuric acid, that is also colorless. And these two are bases, dilute sodium hydroxide. Now you all can see this is sodium hydroxide crystals. Okay children, it means solid sodium hydroxide, and this is the colorless dilute sodium hydroxide solution. And the last one is dilute calcium hydroxide solution. Okay, and this is the solid calcium hydroxide. Okay children, so what are the indicators that we are going to use now? Here we already used these two indicators, red litmus, blue litmus, and here we have the pH paper. I hope you all remember I explained you about pH paper. By using the pH paper, we can identify what are the strong acids, what are the weak acids, and what are the strong bases and what are the weak bases, because it has a special color code. I hope you all can see this color code. So it ranges from 1 to 14. So pH 7 is the neutral substance. pH 1 to 6 indicates acids, and pH 8 to 14 indicates what is that? Bases. Okay, so the color of the pH paper is yellow color. Okay children. And we have two more indicators. This is methyl orange. Look at the color carefully. And this is phenolphthalein, a colorless solution. So we are going to test these two acids and two bases with these 5 different types of indicators now. Okay children, so watch carefully what are the color changes that take place. First of all, I am going to take litmus papers as the indicator. So you all can see that I have placed litmus papers in front of each of these solutions. So we are familiar with this experiment because we did this type of experiment before. Observe carefully. So first of all, I am going to put dilute hydrochloric acid on these litmus papers. Observe carefully what happens. So does the color of the red litmus paper change? No. What about the blue litmus? It right away changes to red color. Okay. And now we will take dilute sulfuric acid. So what happens to the color of the red litmus? No change. What about the blue litmus? Again it changes to red color. So we all learned before that color of the litmus paper in acidic medium is always red. Okay? We will check with our bases. We are going to check with dilute sodium hydroxide first. What happens to the color of the red litmus? It changes to blue color. In blue litmus, there's no any change. Now we will check dilute calcium hydroxide with these indicators. What happens to the red litmus? It turns into blue color. And blue litmus, there's no color change. Okay children, so we already discussed about this litmus paper with acids and bases. You all learned earlier as well that the color of litmus paper in an acidic medium is always red, and the color of the litmus paper with basic medium is always blue color. So that is why you all can see now this is the initial color of the red litmus, initial color of the blue litmus. So you all can see dilute hydrochloric acid and dilute sulfuric acid. They are red, they give red with litmus paper, right? And dilute sodium hydroxide and dilute calcium hydroxide are two bases, and the color of the litmus paper with basic medium is always blue color. Okay, children? Right. Okay, children. Now we are going to move to our step 2. That is doing the same activity with pH paper. So what is the color of the pH paper? That is yellow color. Okay. So first of all, I will put a few drops of dilute hydrochloric acid onto pH paper. So I explained you that pH paper gives a color range. Look what happens, children. What is the color? It is red color with dilute hydrochloric acid. We will go along with this color code given. Look at this one. You all can see 1, 3. Right, number 1 to 3 gives red color. It means they are strong acids. Okay, children. Now we will take dilute sulfuric acid. Again it turns into red color. Okay, so here you all can see 1, 3, those are coming under strong acids. So the pH paper's color with these acids is red color. Okay, children. Okay, we will move to the next one, two bases. Dilute sodium hydroxide with pH paper. What happens, children? The color changes into blue color. Look at the color code, children. Again, you all can see 10, 12, 14. The pH value 10, 12, 14. They are coming under strong bases. They give the yellow color of the pH paper changes to blue color with the presence of strong bases. And finally, dilute calcium hydroxide. So again you can see it gives a similar color. Okay, children? So according to this color code given, you all can see red color means acids and blue color, blue purple range, it means bases. Okay, so it's very clear that acids and bases can be identified using this pH paper as it gives a clear color code. Okay, children? Okay, now we will move to the third step, using methyl orange how to identify acids and bases. I already explained you that what are the properties of this methyl orange and phenolphthalein, all these things, and even the color changes that take place. Okay, so here in this test tube rack I have these two acids. Now the first one is dilute hydrochloric acid and then dilute sulfuric acid. And here we have dilute sodium hydroxide and dilute calcium hydroxide. Two acids and two bases. So first of all, I am going to take this methyl orange indicator and put 2 drops to each of these test tubes. Observe carefully what happens. It clearly changes the color. We will take dilute hydrochloric acid. It turns into red color. And even dilute sulfuric acid turns into red color. So what is the color of methyl orange in an acidic medium? It is red color. We will move to our bases. Dilute sodium hydroxide. It turns into yellowish orange color. We can consider it as yellow. Dark yellow color. And even dilute calcium hydroxide, it turns into dark yellow color. Okay, so it means what is the color of methyl orange indicator in basic medium? That is yellow color. Okay children, now our last step, we are going to use the same acids and bases to test with the phenolphthalein indicator. So here again in this test tube rack I have the first two test tubes acid, the next two test tubes bases. Dilute hydrochloric acid, dilute sulfuric acid, dilute sodium hydroxide and dilute calcium hydroxide. Okay. So I am going to put 2 drops of phenolphthalein indicator to each of these test tubes. Observe carefully. You can see how the color changes with bases. Okay. So what is the color of this dilute hydrochloric acid with phenolphthalein? Colorless. Even dilute sulfuric acid is also colorless with phenolphthalein. What about the two bases? The bases instantly turn into bright pink color. So it's very clear the color of the phenolphthalein in acidic medium is colorless. It means no color change. And color of phenolphthalein in basic medium is pink color. So after doing this activity, it is very clear that there are different types of indicators in the laboratory that you can use to identify acids and bases. Right children? So you saw what happened when I was showing the experiment. It was very clear using different types of indicators we can identify acids and bases. Do you remember the observations? So look at this. Now this observation is related to methyl orange. I will write from here. Methyl orange. And this side, phenolphthalein. Phenolphthalein. Okay children, so methyl orange and phenolphthalein. So here the first two test tubes contain dilute hydrochloric acid and dilute sulfuric acid. Then dilute sodium hydroxide and dilute calcium hydroxide. Here also the same, right? So the first two are acids, the next two are bases. Look at the color, you can see with methyl orange, acids give red color, bases give orange color, right? Or dark yellow in color. Look at phenolphthalein indicator, the first two test tubes are acids, next two are bases, right? So with acids, phenolphthalein is originally a colorless solution. So it does not change the color with acids. It is still colorless. But with bases, you remember it gives a bright pink color. Okay, children? So what about the pH paper and litmus papers? Here you can see the original colors of this is the pH paper, blue litmus and red litmus. So you observe what happens. We are very familiar with our litmus papers because we did an experiment with litmus paper before, right? So you can see the first two beakers are acids and then bases. Dilute hydrochloric acid, dilute sulfuric acid, dilute sodium hydroxide and dilute calcium hydroxide. 2 acids and 2 bases. Look at the color of the litmus paper with acids. You all know that it is always red in color. It means red litmus paper does not change the color but blue litmus turns red. Okay. But with the bases, the color of litmus is always blue color. Red litmus turns blue but blue litmus does not change the color. Okay. What about the pH papers? You can see these pH papers, it is reddish orange color with acids. So what is the conclusion? These acids are coming under strong acids. Okay. And with bases, pH turns dark purple in color, bluish purple in color, right? It means these bases are strong bases. So after doing this activity, it's very clear acids and bases give different colors with different indicators. Okay, we will write that. acids and bases give different colors with different indicators. Different indicators. Okay, acids and bases give different colors with different indicators. So what is the conclusion? We can use different indicators to identify acids and bases, right? We'll write that. Different indicators can be used to identify acids and bases. Okay, so the conclusion is different indicators can be used to identify acids and bases. Right, so with this part, we have completed the lesson. So it was a very easy lesson, right? Do you remember what we learned under this lesson? We will go check the summary of the lesson. So we will go from the beginning. We use acidic, basic and neutral substances regularly in our day-to-day activities and also in the laboratory. So after learning this lesson, I hope it's very clear that there are different substances that you use in your day-to-day life are coming under acids, bases and neutral substances. Okay? Next one. Identifying acidic and basic substances is useful in day-to-day activities. Why? What is the important? Do you remember we learned sometimes in order to reduce the pain due to bee sting, we have to apply sodium bicarbonate, right? Those type of instances are very important in our day-to-day life. So identifying acids and bases are very important in our day-to-day activities, right children? So different kinds of indicators are used to identify acidic, basic and neutral substances. The things that we can use to identify acids, bases and neutral substances are known as indicators. And lemon, vinegar, tamarind, gamboja, some of the acids that can be found at home. And sulfuric acid, hydrochloric acid, acetic acid. What is acetic acid? Acetic acid is the acid that we can find in vinegar, right? So sulfuric acid, hydrochloric acid, acetic acid are some of the acids that can be found in the laboratory. And soap, lime water, shampoo, ash are some of the basic substances that we use at home. And sodium hydroxide, calcium hydroxide are some of the basic substances that can be found in the lab, okay? And sugar, common salt, kerosene, glucose are some neutral substances that are used at home. So after learning this lesson, it's very clear there are different substances we use at home can be categorized as acids, bases and neutral substances. And there are different types of acids and bases that we can use in the lab. Right. We have completed the lesson, but there's one more thing we have to do. What is that? Yes, that is exercise. Now remember children, when you all do the exercise, you all have to write the answers before me, right? So you have to write the answers for all the questions in this exercise and then you have to watch what I explain and you can cross-check your answers with my answers. Okay children? So we will go to the exercise part now.